Now we have to find where is a function is concave up or concave down. And for that we have to start with the domain again, which is R, so there is no bad point on our number line. And we will use these rules. To do that, we have to find the second derivative of the function, which is the derivative of the first derivative. So we have 12x squared minus 4. Now we have to find the zeros of the function. To do that, we have to solve this equation, where x squared is equals to 4 over 12, which is 1 over 3. So x is equals to plus or minus 1 over square root of 3. Let's put these numbers back on our number line. We have negative 1 over square root of 3 and plus 1 over square root of 3, and we get intervals like x is smaller than this value, x is in between these two values, and x is greater than this value. So we get a table like this. We know that the second derivative function in these points are 0, and we have to find the signs of the second derivative function in these intervals. To do that, let's draw the graph of the second derivative function. We can see that this is a quadratic function and 12 is positive, so the graph should look something like that. And since we have two zeros, it must look like this. Here is our 2 0 points. We can see that if x is smaller than this value, the graph of the second derivative function is above at the x-axis, so the second derivative function is positive here. And we can see that here is negative, here is positive. Now let's put back these signs into our table. So here we have positive, here negative, here positive again. And according to these rules, our original function here is concave up, here is concave down, here is concave up again. It wasn't the question, but we can see that in these points we have inflection points, so we can get a better picture how our original function should look like. This point is somewhere here, this one is somewhere here, so our original function should look something like this.